Greetings, dear ones. I'm Kryon of Magnetic Service. I want you to feel the stillness. It's not often that it is this way. The rocks are listening. If I told you, dear ones, that the rocks were alive, what would you say? For they don't match the scientific identity or definition of life. I've also told you that there will come a day when the definition of life will actually have to change. For science will come to an agreement, I will call it, a confluence of discovery, when they start to look at multidimensionality, identify it for what it is, and be able to measure it. And when they do, they will see the things in nature and rocks and trees that will redefine what is alive and what is not. And so when I say to you, the rocks are listening in a certain way, not defined the way you think, they are. I would like to talk about science in this little period of time in a way that would seem to be uncomplimentary, but that's just the way it seems. It is the science of this planet which has driven you to this place. It's the science of the planet that will allow you to discover that which will then prove spirit. So it's coming, and it will be scientific. But the science of today has some biases. I would like to talk about that before I talk about that which is here in front of you. There are many kinds of science. There are the disciplines of science, the various studies. But scientists will tell you that truly there are two groups. The one group is trying to study the things that are and explain them. The other group tries to take that which is and project it to future causality. That means that they will be the ones who will invent that which you will use in the future. And the various kinds of science have different kinds of evidences. Various kinds of sciences don't have a lot of evidence, so they create the machines that will produce them, or the experiments that will show them. And so they are creating that which they will then examine, and that then becomes their evidence through the creation. Then there are the other scientists that have a multitude of evidence in front of them all the time. Astronomy is one of those. The evidence is always there, always available to be studied. That kind of science is deciding what happened, when it happened, how it happened. That is much like geology. A geologist is faced with a multitude, a confluence of evidence that is so astonishingly great that they often don't know what they're looking at. Not only that, but the eons change that which they see. So as they take a look at one thing, for instance, the things that may be obfuscated completely is what happened to the eons before that which they're looking at. I want to tell you about the biases that occur. In science, it is supposed to be fresh. The scientific method is supposed to be one that excludes things that don't matter and includes things that do. It is supposed to be a method that is unbiased, but it is very biased. Let's take the one that I speak of often. Scientists in a field of their expertise believe they know certain things about what they've studied. And those certain things accumulate and create a bias so that they think they know where to look for the next discovery. So the bias becomes that which they think they're looking for. And then they design the experiments for that bias not of a surprise, but of something they think is there, and that's the design of the experiment. The classic was the search for junk DNA. I've given to this before. For over 30 years, laying out before you was the chemistry of DNA that could not be solved. 90% of the chemistry of life itself was a mystery. Right up to the modern age, until 2012, it was considered unsolvable, even that which you would call junk, because there was no purpose that they could see. And the reason that it was so elusive is because it was being studied by life scientists, chemists, and biologists, because they were looking for codes. They were looking for what they expected based upon what they saw in the past. They had made up their mind. This is where it's going to be, and looked there and found nothing. Then we told you later that the big discovery was from linguists who study word patterns, because in that 90%, there was language. There was information. It's classic. The other one, which we haven't spoken of just yet, but we will in several weeks, is at the Large Hadron Collector. There they put tremendous energy to put the atoms of hydrogen together at almost the speed of light, crashing them, recording the explosions, and seeing what flies off. And they have trillions of photographs of what flies off. How do you analyze that and make any sense of it? They will tell you, well, they've designed programs that will look for that which they believe is there. Dear ones, they're going to find some of that, and in the process, they will miss what is really there, because their program doesn't include looking for it. So you see, even in the highest physics, there is bias of the way you think things work, and then designing the experiment around it. The great bias of geology is this. As long as you've been alive, dear ones, on this planet, geology works slow. There is the bias, therefore, that all geology has been extremely slow. And when you see something on the horizon, you make up your mind how long it took for it to be what it is. And you plug in what you believe to be true, that the erosion factors, the types of stones, the hardness and softness all weigh in to a very, very, very slow process. And that, dear ones, is completely wrong. What the geologists don't expect is that when the earth was being formed in those millions of years ago, there was tremendous upheaval. And the processes involved were enormous. The weights of water on a newly formed earth, enormous. Things happened far faster than they thought. There are a few geologists who got the point with the explosion at Mount St. Helens, when they got to see what they thought previously had taken hundreds of years happen overnight. And they realized that the process of a volcano can create things they didn't expect in a time frame that was never taught them in school. So let me tell you what you're looking at. And I'm going to align it yet again with that which you've seen in the Grand Canyon. It's hard to describe this. And in geological terms, I will not. In plain English, I will. What you're looking at right now would have the attributes of thousands and thousands of years of wind erosion. There is a pattern to wind erosion and rain erosion. That's basically what you see. But underneath that, dear ones, what is really obfuscated and not seen as the way it is the ocean that was here. Not just an ocean, dear ones, but an ocean on the move. How do I tell you this? Almost to the continental divide, that which you call the Western United States had several major upheavals to literally let the ocean in and wash it back, with land that tipped up and back again. Can you imagine that force of an entire ocean being released and coming in? And in its force for perhaps hundreds of years, then to be reversed and let out again. I'll tell you that that Grand Canyon was cut in less than 300 years with an ocean ferocious, something you've never seen on this planet at this point. This planet is peaceful now. It's done with that kind of geology. It's done with that massive amount of movement in short amount of times. That's what the earth was like. And if you could see this, you would understand that underneath what you think is wind erosion is water erosion. You can see what sticks up here, and the bed of the ocean that is here, they were islands. Waves crashing against them, eroding them to what you see today. That was the beginning. That was the mold of what you see today, which was then later eroded more with wind and with rain. Those who are here and live in other areas, no, you'll find seashells everywhere. This was an ocean. It wasn't a calm ocean. It was an ocean on the move. As the plates would lift and turn and lift and push, it was more than you could ever see. Movement, which was more than expected from any geologist. Quick, fast, ferocious. And it made the hard cuts that you see everywhere. Straight up and down. A lot more than wind and rain, even through millions of years. So I want you to think of this, and I want you to remember this day, and I'll say it again because there'll come a time when geologists will say, yes, we acknowledge this now. That's the science lesson for the day. I want you to look at these things with a different eye. I want you to look at the confluence of nature which created the beauty that is today the desert. And I want you to look out and see the ocean bed before you. Imagine the crashing waves, an ocean that was never still, on the move, and how through hundreds of years and thousands back and forth this occurred. It's the reason there's a delta on both sides of the Grand Canyon, where it flowed one way and then the other way, and then one way and then the other way, cutting what you see here in a majesty that you can look at today. Controversial? Of course. And so it is.